It's an interface to interact with the operating system. So an application, it interacts with the operating system through something called a system, right? So let us try to go one by one and see how we can add a system call. So what I'm going to show you is I am going to use a system call by the name get year, right? This is the name of the system call. Get GETYEAR. This is a system call I want to put in my system. And what this will do is it will provide me the some text, right? So whenever I would like to call this system, ask the system call, it will give me some text, which is the year at which this xv6 was conceived. So let's see what we need to do. Okay, first of all, we will be handling 5 files. Let's look at those 5 files that we are going to handle. All of you are with me into this xv6 directory?
Yes.
Okay,
Yes,
let's
sir.
begin with the first file. And the first file we are going to look at is called syscall.h. Where do you get it? Well, you will have it here. It's called syscall.h. This one. Okay, let's open this up. Syscall.h. Let's see what is it we have. Syscall.h. Do you see this? All of you?
Yes, sir.
Okay, there you go. So what we have in this file is some numbers. Every system call is identified by a number. These are the current system calls that are supported by xv6. See, every system call has a number. For example, the system call is fork. It is having a number 1. Exit has a system call which has a number 2. Wait has 3. Pipe 4. Read 5. Kill 6. All these system calls are prefixed with a word sys underscore. So this is a header file. What is this? This file, it contains, as you see, 21 system calls. Each system call is given a number. We are going to add our system call. So we should also give a number to our new created system call. So the first thing that you are going to do is you are going to add this to this file. What is it? Let's say we give the name of our system call as get year. Get year is the name of our system call. We are going to associate a number to this system call. And because already 21 system calls are there, let us give a number 22. Clear? So we are adding a system call called 22. That's the first step we do. Okay, let's done. So we have given number 22. What did we do? We defined it in the header file and we gave a preprocessor directive saying that I now have a system call number 22, which is a system call given by a preprocessor directive get year, sys underscore get year. So whenever you will be using this string, it is actually referring to system call number 22. Kernel understands it in this way. That's the first line. Okay. Next, the next file that we are going to look at is syscall.c. Syscall.c. This is the file that we are going to look at. Syscall.c. I have already opened it here. Now, understand this way. Suppose you are going to add a system call, right? You need to do three things. First, give a number to that system call. We just did that. Define it in the header file. Second, give a pointer that will point to that particular system call number. Okay, a pointer for that. Where is it? It's here. I just removed. I've already written it down. Now let's try to understand what is this. Well, this small sys underscore get here is a pointer to a function that I will be writing now. Which function? The function that will be containing the definition of the system call. Go back to the definition of system call. What is system call? It's a function. Whatever, very similar to how you write functions in C, system call is also a C function. So the definition of that C function will be written somewhere else. A pointer to that particular function is this sys underscore get here. Well, what does this line mean? It means that the pointer sys underscore get here, which is a pointer to the function, will reference to system call number 22, because system call number 22 is mapped to this particular preprocessor directive. Not the preprocessor directive, the one defined in that preprocessor directive. System call number 22 is capital SYS underscore get here. This is now mapped to a pointer to a function small sys underscore get here. Right? So what we have done is we have added a pointer to the system call, and it also keeps a reference to the corresponding number of them. That's the first step we are going to do in system call.c. There's one more step to be done. What is that? You know that every function has a prototype. The system call that we will be defining somewhere later will have a prototype. The prototype will be defined in this system call.c. This is the prototype. This is the prototype, which is sys underscore get here, which will take no argument, so void, and will return an int and of type extern. This is the prototype of the function that we are going to write. Which function? The system call function. These are the two things we are going to do in syscall.c. Let's save that. This part is over. I repeat, I had syscall.h where I defined the number, which was number 22. I gave the name of that particular system call there. I opened syscall.c, that's the second file. I did two things in syscall.c. I defined a pointer to the function that I will write later on. And I also defined its prototype. Done. Now let's proceed towards, so the function prototype is there. Now I will actually implement the system call, which is done in sysproc.c. I have a file called sysproc.c. This is the file where I will be defining my system call. Let's open that. In sysproc.c, I have already written my system call. This is the definition, function definition here. Okay. See, look at that. What I am planning to do in this system call, this get here system call will just return this string 1975, the year in which the thing was conceived. Simple definition. Look at sysproc. All the system call definitions are defined here. Look at this fork. That's the fork definition. Look at this. This is the exit definition. So here I am defined my sys get here system call, and whatever I want to do in this, whatever the functionality of the system call would be. right? Done. These 3 steps are enough. My system call is ready. So I touched upon system call .h. I touched upon system call .c. I defined the prototype and the function pointed to the function there. I defined the system call in sysproc.c. Now my system call is ready. Not yet. Why? Because I have added the system call, but how will the user programs execute them? Recall that a process executes in 2 modes, kernel mode, user mode. A user mode program will be executing the kernel mode functions by putting a request to that kernel through the system calls. Well, how will the user program put that system call request? There must be some interface. For I will require this file. It's called usis.s. You have a file called usis.s. This file is what I need. This is the 4th file, right? Let's open that. So usis.s. Here, I am building an interface. Which interface? An interface for a user program to call the system call. I am building this interface. And how am I doing that? I am using this syscall and passing within that as an argument the name of my system call, which is get here. Okay, that's what I did in usis.s. Okay, now so usis.s is, that's all. Let's save that. Okay, that's the first thing we do. Now we have a file called user.h. So for a user function to access that system call that I just created, 2 files have to be modified. Usis, where you declare the system call, we just did that, and a header file where you'll be defining the type. Okay, that's it. Okay, so I'll be putting this here. This is the function which a user program would call. Let's try to understand. This is the function that a user program would call. So any user program would call the system call that you created by using this function called getHere. This is the interface. Using this function would eventually call the system call that you have created. And the system call will be executed by the kernel. Okay, fine. Now, done. We are ready. Not yet. Why? Because we need a user program to test. So my job is okay. My system call is ready. I have created my system call. I have put it in the proper places so that xv6 kernel can execute them. I have created an interface so that user programs can call the system calls. Now I have to test whether my system call is working correctly through a user program. So I have written a user program called test underscore get underscore year. This is the name of the program I have written. And I have written a simple code here which would print this line: Unix was released in the year. And I am providing as an argument to this system call that I created. I created a system call and I'm accessing the system call through this function called getHere, which I included in user.h. So I want this program to test whether my getHere system call is working correctly. I have written this. Now it is time for me to make some modifications in the make file. Now go back to the previous class. we saw how to include user programs. How did we use user programs? We make modifications in the make file. First of all, your test get year should be in the same folder as the make file. Let us check. My test get year is already there. Okay. Let me make modifications in the make file so that when I execute the kernel, when I compile the kernel, this test get year program gets included. Okay, and test get year program request for a system call. So if it works correctly, that means the system call is correctly called and it's executing. Let's see. What are the two steps that I told you to change or make in the make file? Anyone?
Sorry, user process, impros.
Let's go to uprox. Here is uprox. What will I do here? Add the name of the object file or the executable. What is the name of the executable? Test underscore get underscore year. This is the name of the executable that will be created. And I will give the name of the source code in the extras. So here I will add test underscore get underscore year dot c. Is it correct? All of you agreed? This is the source code in the extras and objects will be object code. Save. Let's open QEMU to see if things are working correctly. I will compile this again, make clean. Let's open up this. I did not save it. Yeah. So recompile. Then let's say make. Done. Then let me run QEMU. QEMU started. Let me check whether this test get year has come up. Well, this is a test get year that has come up on the right hand side. You see? So my user program test get year has been included. Remember what is test get year? Let us check test get year. Oh, this is the executable, so we cannot see that. So let's run test get year. Yeah. Right? What did test get year? What is expected of test get year? It says printf Unix was released in the year %d. This %d should come from this function. What is this function? Well, this is the function that is defined in sysproc. Right? This is the function that I have defined here. Which is that? It's a system call. And this user code is using this function get year, which is calling this function. So the user program, which is my test underscore get underscore year, is making use of this library called get or this function called get year, which is nothing but a system call execution. Right? That's how the function gets executed. Is it clear to everyone? So overall, we made changes in 5 files, right? Initially, we gave a number to the system call, included it in the header file. We defined the syscall.c. We defined it in sysprog.c. That's all about system call. Then we created an interface for the user programs to interact with them. We defined a function call and tagged it with the system call. And then to validate that it is indeed working correctly, I wrote my own program so that that can make use of the system call. Very similar to how we write our programs, which makes use of fork, exec, and all that. What are they? They are also system calls which have been written in Unix. So whenever you are using this fork command, you are actually calling a system call. That's exactly the same thing. Now the name is get_year. That's the system call. This is how you will be adding a system call, right? So what is your job? Your job is to read this particular assignment, number 1. Assignment, lab assignment 4, part 1. Your first task is to modify the xv6 kernel and print out a line for each system call invocation. It is enough to print the name of the system call and the return value. You don't need to print the system call arguments. My suggestion would be, whatever I have taught you today, you need to first repeat that with a different system call. Suppose you want to add a system call that will be maybe display the date. Okay, display the date. Repeat that. Add a system call of your choice and validate that it is working correctly by writing a user program and calling using the system call in your program. Validate that it is working correctly. Okay, that's the first step. Next is this. All the system calls that you are going to use, everybody has a number. When you boot your system, when the xv6 gets booted, it should display these numbers. I want you to write this program. You have to dig deeper into the kernel and find out how to do that. Hints are given. Okay. Modify the syscall function in syscall.c. You have to add a printf statement. Where and how, try it. Once you are done that, the next step would be, I told you to add your system call. There are 2 options. You can either go for date system call or you can go for a PS system call. I hope you remember what a PS system call does in Unix. Process info. It gives you a process info. So your task is to add a new system call that will get an information about the processes running in the system. Okay. It is not there in xv6. It is there in Unix, not in xv6. You have to add that. So this is the prototype of the function that you will create. It will take PID, it will take a pointer, and will return is a structure that describes the process containing information, process name, process ID, etc. And it will return an integer, which is the PS. The PS command is successfully executed. Okay. Here's the source code that you can use. Try this. 15 days of time to complete these two lab assignments. Clear to everyone? Yes. Any questions?
Sir,
Sir,
why we are
possible
not using